So I got asked by a few people to do a little breakdown of what happened to the little Formula Offroad build. As you can see, it's kind of taken apart. On the last video, I had some issues with it where it stopped moving. It was hard to tell what was really wrong with it at the time, but because we already know that this runs on SCX24 axles and we were running pretty high RPMs on it. The first guess everybody had was that the axles, the worm gears were actually damaged. My first guess was that the actual dog bones were the issue, where that actually didn't turn out to be the problem. So I'm really happy about that, because usually when those stick out a little bit, you snap the shaft because they just get stuck on the axle itself, and everything just snaps and breaks and gets destroyed. So I was really happy that that wasn't the issue. Now the issue I had was mainly my problem, my doing. This is the pinion that I'm using with the motor. As you can see, there's a lot of gunk around it now. That's metal, mostly aluminum actually, and that came from the spur. And the reason that came from the spur is that right here, that set nut that we have that holds the spur in place, that came flying out of there at some point during the run. And what that did, of course, it caused the spur to kind of like just wobble back and forth. And as you can see, let me see if I can find the ones that are really messed up. So you can see the teeth, they just got all destroyed. So this is an issue you're going to run into if you're trying to run really high RPMs. Please make sure to secure that nut really well, because these aluminum spurs do not like to be abused in every kind of angle. So as you can see right there, that spur is gone. There's no sense in using it again, because obviously it's not going to mess up this hardened steel pinion, but I don't want all of that gunk going into the holes and inside of the motor and even messing up my bearings. So that's done. I'll have to put a new spur in there, and obviously I need to get another nut to put in there. I'll have to look inside to see that the bearings are okay. I mean, everything is spinning pretty good, so I don't think that the bearings got all messed up on the inside from the pushing on this side. You can see there's some motion going on there, but usually that gets taken care of once you tighten up the nut there. But like I said, I have to check them, because if this bearing was damaged, then of course I have to replace it. But yeah, that was the damage that came from that first run. Again, not a problem with the actual drivetrain, mostly just my issue where I didn't tighten that enough. And then when that happened, this guy fought with that spur as much as it could, and then eventually it just pushed it up. So the bolts that I had holding it just kind of got pushed up on the motor plate, which in a way is a good thing, because had it gotten really stuck, more things could have broken. So that's where we're at with that one. I'm going to be swapping that spur. I'm going to be making the plate cover a little bit better at covering, so I want to make sure that nothing just gets in there. May cover the back as well somewhat. We'll see what we do there. And worm gears, perfectly fine. Nothing wrong with those. There's still plenty of grease in there, so thankfully that hasn't been affected. But that's mainly because I've kept the RPMs to a manageable level. This motor is rated at 4100 kV, as you can see. The Furitek Godzilla, which is the one that I built this rig for, is 4000 kV. And I've gotten a lot of messages from people stating whether that's a good or a bad decision for this kind of rig. Well, the thing is, you have to look at things in a way that this is meant to be both a Formula Offroad and a rock racer. And for it to be able to be a rock racer, it's going to have some slow speed control as well. And 4000 kV is kind of like the best all-around RPM that you can get, where you can get low speed control and still get really good top end. So we figure we stop at that. Also, the other thing is this motor is 4100 kV, and the amp draw on this at full power is within the specs of the Tegu, and that is another reason why we went with the 4000 kV. We don't want to put a motor like, for example, this guy right here, Toro 6100 kV motor. This motor has 40 amp spikes, and that is something that this ESC is not designed to handle. So this is the motor that we're going to be using at the end, just for the runs on this one, for just for fun, because I'm not doing the rock racing part of it right now. So I really just want to get as much wheel speed as possible without having to mess with overdriving the axles anymore, and and putting like huge pinions. So I figured I'd put the 6100 kV, and that'll give me another 50% increase in speed as compared to this one. That's not gonna be the first one though. I'll run this one first. This is 4300 kV, so we get an extra 200 RPM per volt, and that'll give us a little bit extra speed, so we could keep testing the axles and all the drivetrain and dry shafts. We don't want to have any of this stuff snapping out. Like I'm running the Enduras here, and this one, for example, it came from the factory with this pin sticking out more to one side than the other. I don't want to press it in to make it even, because what that does is it kind of loosen up the fit on the inside, and then it just snaps out. So I've been running it like this, but these are the kind of things you want to look at when you're running a super high speed rig like this one. That could become a problem later on. I'm gonna run it till it breaks, but I'm guessing that will be one of the parts that will come apart first. Hopefully not, but it's one thing that I keep an eye on. Like I said, I'll run this one for testing first. We'll get a little bit more than the Castle, and then of course we'll go to this big boy here. We'll see how I do the pinion, because as you can see, this has a really short shaft. I'm pretty sure that's my fault. I might have cut that shaft before, and I really don't remember for what. No, actually I do. Okay, so I cut that shaft because I put a gear reduction assembly in front of it for when I was running the sand racer with this motor. So that was my fault. I cut that shaft, so now I'm stuck having to use it kind of like this, which I may have to use a little spacer to push it back a little bit, or make a mount that's going to push it back a little bit so it'll line up with the spur. Anyways, that's where we're going to go with that. So yeah, very happy that it wasn't anything really major, and it was mostly my fault, so I can fix that. And we'll be making some more videos. Let me see, that was kind of cool. I like that black. Anyways, like I said, that's going to be the next thing. Oh no, I'm lying, there's something else. Alright, so like I said, that the Tegu is not rated for the 6100 kV. So what I'll do is I'm gonna run this guy. This is a 60 amp that I've been using forever and ever, and it just never breaks. So this is for a 1/10 scale. It's a Hobby Wing Easy Run. You can get other 60 amp ESCs, they're 1/10 scales, but I think I could fit this one in there pretty nicely. And I know it's overkill, but because it's just a rig just to make videos for you guys, I'll fit this in there nicely, and the 60 amps will give us plenty of overhead to run this motor until the motor dies or the rig dies or whatever. But the ESC is not going to have any issues. So yeah, this is going to be the power supply for the motor on this one. And but not that you really need something like that. This is built for the Furitek Godzilla, and that's a 4000 kV motor, which is perfectly suited for that ESC. Okay, so that's that. Anyways, I don't know, my videos are way too long. Anyways, thanks for watching, guys.